Let us take a look at what are the best practices for writing secure smart contracts. In this entire lesson, I'll be outlining 7 best practices, and I've split this into 2 videos, apart from the introduction one that we've already seen. So let's go. The first set of best practices for writing secure smart contracts. Monitor and upgrade your dependencies. You might be using other dependencies from either OpenZeppelin or elsewhere. Make sure that you are using the latest versions. For example, the ERC20 tokens, the 721 tokens, these are common dependencies. The counter contracts, these are some common dependencies that you're likely to use in your contracts. But make sure that they are upgraded and you're using the latest versions. You can't be writing a contract with version 0.8.6 and expecting your ERC 721 of 0.8.0 to work and behave the same way. If you don't monitor them and don't upgrade these dependencies, there could be, of course, other dependencies in your dApp as well. If you don't monitor or upgrade them, you will find unusual behavior while you're after deploying the contract and while you're trying to interact with it. Second, and one of the most underrated best practices is to use stable Solidity versions. The recent version of Solidity that has been released is 0.8.17 at the time this video was shot, but I don't think it is stable yet. The last stable version I think is 0.8.16, but you should definitely check that out. I've seen that recent SDKs have started using greater than 0.8.15. So make sure to see what is the latest stable Solidity version and use that version. Avoid using Solidity versions that may have breaking changes that you haven't gone through yet. And avoid floating pragmas. For example, a lot of us have the habit of writing greater than a particular version, lies between, say, 0.7 and 0.9, right? Now, between 0.7 and 0.9, there are lots of Solidity versions with multiple breaking changes at different levels. So, I suggest strongly to use your Solidity version like this. Do not use like this, just mention a specific version, right? Right now, I'm going to mention 0.8.16 because that's the compiler that I've chosen. And I would suggest to mention a specific version so that you are aware as to what are the changes that are there and what this version supports. So avoid floating pragmas. Don't have greater than, less than, or in between two ranges. Have a specific pragma version. Let's move on to the second set of best practices for writing secure smart contracts. In this, the first point that I would like to highlight is use the check effects interaction pattern. This is a very talked about pattern and a very easy way to kind of write a good smart contract. What does this mean, right? This means that go for checking first. That is, your required statement should be on top. Effects, that is, update value based on whether a particular check passes or not. And then you can interact, that is, make smart contract calls. How would this look like when you are writing a smart contract, right? So I'm just going to write a dummy modifier right now over here. So I'm going to say that this modifier checks for a, we don't even need a modifier for this example. Let's say ABC, okay, public. And then the first thing you should always have requires, right? Say require message dot sender not equal to address of 0, and then say sender cannot be 0 address, right? So this is your check. And then you are going to have an effect. That is, you are going to say something like address A is equal to message dot sender, only if they're not equal to 0. And then you do the interaction part, that is, call another smart contract or whatever you want to do, right? So this is the way you should write your body of the function in a Solidity smart contract. The second and the third one are in fact, all of these other points on this slide are fairly simple. Always fix the warning, irrespective whether using remake, hard hat, or anything else to develop. Whatever warnings you're getting, make sure that you're fixing the warnings. You may get warnings on things like this particular variable is not used, this particular variable is defined, but its value is not being consumed. So you want to know that, there is a dead variable or there's dead path. So you want to fix that. Keep it simple. It's a rule of software development. Keep it simple, silly. Don't go overcomplicated, especially when you're writing contracts that are dealing with financial transactions or that are holding a lot of money. Make sure that it is as simple and as cohesive to understand as possible. And of course, keep it as modular as possible. Try to split your entire logic into functions instead of keeping one function, which is very, very logic heavy. So make sure that you are bringing enough modularity into the code so that it is simple to understand and also to execute and less prone to errors. Let's go to the third one. Now, this one is is an interesting one, where the first point over here is always protect withdrawal functions. What that means is if this particular smart contract is going to hold some balance, make sure that if you are writing a withdrawal function, something like withdraw from this smart contract, make sure to have access specifiers. So the modifier that I was going to go for, right, something like only owner, make sure that only an owner can actually, take out the funds from this particular function. Or you can have also things like make sure that you have requires sufficient checks inside these kind of functions where you are dealing with funds. Avoid self-destruct, because self-destruct can be used to make calls, to make to create latency issues, or to drain ether, or to, in fact, just stop your at a point where, it's not able to proceed further. Especially whichever contracts are dealing with funds, it is very much possible to manipulate the contract using self-destruct, right? An external contract. Modifiers should not update the state. Modifiers like this should always check for things, right? These should largely come only when you're checking. It should not update the state of a particular variable. For example, if you have a variable UN256, say like gray, I don't know, right? It should not be dealing with that. It should not update the state of the variable. However, you can check the value of this variable in this particular modifier. Then last but not the least, use reentrancy guard wherever required. I suggest using OpenZeppelin's reentrancy guard because that's an already established module, a library that you can just pick up and just use it. And this is one of the it's a modifier that's already written. So you can use non-reentrant, the modifier within your reentrancy guard, and you will be sorted, right? So you have the non-reentrant modifier, which can be applied to functions to make sure that there are no nested or reentrant calls to them. Make sure to double check and ensure that you have the reentrancy guard. It is very simple to add a modifier to your function that you can just add something like this. But of course, you need to import a reentrancy guard from OpenZeppelin here. And you can just add the modifier. You make sure that this function will not be prone to reentrancy attack. So these are some simple yet very, very significant best practices that you need to consider while writing your smart contracts. We'll see the next set of best practices in the upcoming video.